Imagine a world where machines can learn, think, and create, just like humans. Welcome to the age of artificial intelligence. From self-driving cars navigating busy streets to virtual assistants helping us every day, AI is already all around us. It's not just about logic. AI can compose music, generate art, and even come up with ideas we'd never imagine. The possibilities are endless. But how does it actually work? How can machines learn and make decisions like this? Let's break it down. Artificial intelligence is, at its core, pattern recognition and learning. Imagine feeding a computer thousands of examples, like pictures of cats, sounds of voices, or text sentences. The system starts finding relationships, shapes, tones, or words that tend to occur together. It doesn't think like a human. It maps inputs to outputs based on patterns in the data. It's like a function, f of x arrow y, where x is the input data and y is the predicted output. Over time, through repetition and training, the AI adjusts itself, learning which patterns lead to the right answers. Let's see how an AI model actually processes information. First, we represent data as vectors, lists of numbers that describe features. For example, an image might become a vector of pixel intensities. X equals open bracket 0.2, comma close bracket 2 0.5, 0.9, cookie. The model applies matrix multiplications to these vectors. Each layer of a neural network performs an operation like H equals W times X plus B, where W is a weight matrix and B is a bias vector. The result, H, passes through an activation function, like ReLU or sigmoid, introducing nonlinearity. Layer by layer, the network transforms inputs into more abstract representations, until the final layer outputs a prediction like, this image is a cat, with 98% confidence. AI can be divided into machine learning and deep learning. In traditional machine learning, we design features manually. Think of models like linear regression or decision trees. They find simple relationships, often represented as y equals w1x1 plus w2x2 plus b. In deep learning, the model automatically discovers features using multiple layers of neurons. Each layer performs a transformation. HNL equals sigma of WL times HL1 plus BL. The more layers, the more complex the patterns it can detect, like faces, language, or sound. Machine learning is like finding a single equation. Deep learning is like stacking hundreds of them until meaning emerges. AI isn't just theory. It's everywhere in our daily lives. When you talk to a chatbot, that's natural language processing, understanding your words as numerical vectors called embeddings. When your phone recommends a song or a movie, that's a recommendation system using matrix factorization to predict your preferences. R approximately U times V transpose, where R is the ratings matrix, and U and V represent user and item features. In finance, AI models predict market trends using time series data, identifying hidden correlations. In art and creativity, generative AI uses probability and deep neural networks to produce new music, art, and even video, blending logic and imagination. Artificial intelligence is not magic. It's mathematics with purpose. At every step, AI converts data into numbers and numbers into insight. It's all about inputs, transformations, and outputs. The power of AI comes from its ability to learn, to adjust weights, minimize errors, and find patterns invisible to humans. Every improvement, every breakthrough starts from that same equation. Output equals model open parenthesis, input times weights plus bias close parenthesis. The result? Machines that adapt, improve, and amplify human potential. We're entering a new era where math meets imagination. AI is changing how we think, create, and build. If you want to understand it, truly understand it, keep exploring with us. Learn how the numbers turn into intelligence. Subscribe, stay curious, and keep learning, because the future of AI is being written right now.